Okay, good afternoon. I'm Carlos Ferro. This is the Smalltalks 2009 conference. I am honored by the FAST with the obligation of running the coding contest that I gracefully assumed. Actually, I asked for it. It's good for me that FAST is a non-profit organization because they could have charged me otherwise. Let me tell you the deeds and story of a young, brave programmer. This story started long ago in a kingdom not so far from here. Probably you know that kingdom. It started with a kid reading books. This kid soon discovered that what he liked the most to read was actually science fiction and fantasy. In that way, he discovered huge heaps of garbage, but also some valuable treasures that inspired him. Later, he discovered that something called role-playing games existed. This was even better because in those games he could, with a group of friends, have fun and in some way live the exciting that the fantasy adventures produced, but calmly around the table and with snacks. Role-playing games is something I love. They have many elements that I'm very fond of. They have fun with friends, they have humor, spicy dialogues between players, but most of all they are about fantasy, they are about storytelling, and they imply a strategy. Role-playing games are based on stats like we see there. Every player is transformed somehow by the game system in a pack of stats. And the game provides a rule system to solve confrontations and situations. So it is like a little simulation, only that random generators are physical dice, for instances. Talking about simulation, those were the times where I started working with personal computers, and games for personal computers have reached an interesting level of development. This was the time, for instance, of Sid Meier's Civilization. Probably most of all know this game in later versions, but it is always the same. You have some complex tree of technologies to develop. The long-term objective of the game is to produce a sustainable society that can have an economy and produce also knowledge and develop technology enough to reach Alpha Centauri after several hours of gaming. This is a full world of simulation. You have, you usually play with a random map, but you can actually play with the world map. and it has a very complex machinery behind. There are lots of little decisions you take every turn, every round in the game, deciding which you want to develop in every city. But Civilization take long hours of gaming, so at some point I had to stop playing it. Lately I discovered a family of web games, web browser-based games, that have the same spirit and require less time per day. This is one of them. It's Travian. It's free, of course. And there you have, again, a village to develop. You have some technologies, and you have to develop economy, production, because you have limited resources to grow your army, your village, to prevent attacks from neighbors, and so on. It has lots of points of contact with Civilization, and I like it very much also. Well, yeah, I'm going back. Another similar game, but in a science fiction environment, futuristic, is O-Game. Here you don't have villages, but you have planetary colonies, which is pretty much the same. In every colony you decide if you develop minery or deuterium production, stuff like that, that are your resources. And you have also this, which is again a complex technology tree, where you choose which technology is developing first in order to get technical superiority over your neighbors that, as always, are attacking you and trying to catch your resources and stop your development. But again, this started to consume too much of my time. The principles of those games are simple, but once you have some number of colonies, it ends with you looking at the screen every 10 minutes or so, because you need to take actions almost continuously. So I had to stop with that too, and I was happy when I discovered this other game, which is called Thanos, and has what I like, the power of simplicity. Here you don't have a technology tree to choose what to develop. You don't have an army. You have only one character. It's like this one. Only one character with some armor pieces, 4 stats, strength, dexterity, constitution, and intelligence, a very simple combat system, and very few commands to use. So now I can only devote 15 minutes or so and still have a good position in the ranking. The other important thing of this game is that from all the others, this was one that I thought, hey, this I can model in a reasonable amount of time, because the others were a little discouraging because of the complexity. So finally, something that a small talker can model in his lifetime. Well, on 2008, Andrés Balud ran the coding contest, and it was very good and very interesting. It had lots of characteristics, but basically I saw it as a simulation and strategy problem in a working environment. He took something like Dilbert's team, a typical development team where you, as a player, control one of the programmers and had to implement a strategy for this programmer to make the project advance, taking tasks and sending them to review or fixing them and stuff like that in a workflow that involved the rest of his team. I couldn't participate that year. I was very busy at the time with my thesis and other stuff, but I would like it very much. Strongly influenced by his work, I decided for this year implement a simulation and strategy problem, but in a role-playing environment, something simple like Thanos, but interesting enough to be a challenge, with some elements that make it at least non-trivial. This is a summary of how the game is. The game goes by rounds. In every round, the player can send one or more commands through to the server, through basically a web browser or something like that, something that speaks HTTP. The alternatives for the commands are these: increase statistic, so be better at something, work to get money, fight another character, request the full ranking or the statistics of a particular character, request the adventure list, or choose an adventure and take it, do it. Then, after receiving the player's commands, the server processes the actions of all the characters, not only players, because it has also automatic characters with its own behavior and actions, processes everything in the simulation world, and sends to every player a status report, which the player can read and have feedback of the effects of his actions. Well, this is how the scoring is. I made it very simple because I wanted to have one metric to evaluate the general performance. So it is linearly sum up fame, goal, and experience of the player. Fame comes only from combats in a closed system, because you gain fame if you win and the loser loses fame points. Adventures can give gold, experience, and little fame, so it's not completely closed, but it's a little addition. And work yields only money. This is a summary of the game. Sorry. Me parece que sí, porque se mueve. Parece que no anduviera bien el clic.
Para esto y para todo eso. Es el otro que viene de campo. Sé que eso una vez me pasa.
Well, okay. This is how I modeled the character. The first element I tried to model. On this side is a common role-playing character sheet. Note that this is pretty complex, but in this game you only have 4 stats. The ones I mentioned before: strength, dexterity, constitution, and intelligence. The character has a name for obvious purposes, and it has these status functions like the gold he has at some point, fame points, experience level, and life is the statistic you use for combats. Then I modeled the combat because this is a very important part of the game. You combat not only from character to character, but also adventures are solved with a combat, with a random opponent. So I modeled this. It has a few instance variables, but it has some complex behavior, which I will not go into here, but it is the most complex class in this model, because you need a little system of rules to solve the combat in an equitative way. It also has the first random elements in the game. Combats are not deterministically solved. It is a strategy, but it also has a random component. Because, I don't know, when role-playing we are used to use dice, to throw dice. It's very funny, and I decided to include this element. It makes it harder to test, but it's very interesting. Here I also included other interesting element, which is history. Why would you need history for a combat? Because normally as a player, on the combat you are not interested only in who won and how much gold he won, but also you want to see it hit by hit, blow by blow. If possible, you want to smell the blood also, so you need the history. These are the actions that model the player's commands. They are pretty much one-to-one with the commands. For the first beta version, I implemented only these commands, not the adventure part. So they are the challenge, the ranking request that lets you see the list of characters in the world ordered by fame points. It's only for the fame and fighting part. The stat increment, because you need to get your character better and better. Stat request, to know before you challenge some guy if you had a decent chance to win. If you want, you can also go and hit his face. And the work command, in order to get some money in a safe way. For actions, I included a little validator. Validation framework is something that Andrés Balud also thought of. He talked Leandro about it, and Leandro introduced it as a common practice in our development team. So I found it useful here too. Why? Because validators provide useful messages for the user, standard messages that allow you to communicate the user when he is bypassing some rule, some business rule, or in this case, some action rule. For instance, you cannot do a challenge if you are working, so you have a validation about that. That is the way you capture some restrictions, some constraints of the domain, and it has a standard way to inform it. I used it to validate every command coming from the parser, and the results of it went directly to the status report. The word. I had, up to there, I had characters, I had some histories, I had combats and actions, but I needed the place. So I created the world. Believe me, it took less than 6 days. But this is a very simple world. It has the name, it has place to hold the characters, a period, because the time is running, as in every simulation, and again the history, because you need instruments to analyze what happened in the simulation. These instruments are here. You need the time of the world, that's the world period. You had a history for every character in the game to record what he tried to do and what happened with that. And the report, that is the response to the HTTP command, and is produced here as a text. Well, then I needed a little automation, because I needed to introduce commands in the world. So I made these schemas for characters. I had this GUI schema first. It is a bunch of prompters and selection list dialogues that allowed me to choose which action I want to execute, and send some parameters on prompters. And also the random schema to get automatic players to compete with my player. So far so good. It took me around 20 hours of work to build this stuff. But it also were 4 weeks of work. At the end of that term, I had a game that could be played. Was not very exciting, the GUI sucks, but it can be played, and it is a suitable laboratory for simulation. You can take metrics, you can extract them, analyze them, whatever. But still no tests. Not only no S-unit tests, no tests of any kind, no QA. Then I started my research with the coding contest machinery. I started to analyze Andres Balou's job for previous year. He gently sent me his development images, so I had access to all the source code, and he offered to answer my questions. But I know he's very busy with this C stuff and the virtual machine, so I tried not to bother him with silly questions. And having all the source code, I said, well, I will read, I will understand it, and then I will ask him. The machinery has very interesting stuff that I wanted. I wanted a web server for the game, and I never implemented one before. I never studied that technology, so it was interesting for me to see how he used a wave server, visual wave server, and that allowed to have remote commands parsed by your visual Smalltalk code, and he also had implemented automated players because all people in Dilbert's team were automated players, and also had score certificates, which is a very good thing because it has the score and some elements that allow you to validate that score, and it's encrypted, so it's kind of hard that someone with little work could fake up a certificate. How hard could it be if it is already done? I was talking about reusing code, not more than that. Well, understanding and adapting all that stuff took me 15 hours of work. Remember in the previous slide that building the simulation, world and characters and so on were 20 hours of work. So it was the same order of magnitude. It took me 6 weeks. I did very little coding. Almost all the time was reading code. I built 30 subclasses or so. Most of them proved lately unnecessary. But all, yes?
How many classes did the other part, the first part have?
I didn't count them, but I think they are under 100. It's not that big. But finally, all the desired properties that I described in previous slide were there. No test yet, because all of these things didn't come with a test. And I understood later why. Because you have no time. In this kind of development, you have no time to write the test that will be required otherwise. So this was the first lesson I learned with this work, and you can repeat with me. Understanding code written by other people is always hard. No matter how well written it is, indeed. You have to adapt yourself to other people's mindset, and that is hard. It's a lot of work, and possibly much work than you expected. Then I decided to publish the first beta version. So Visualworks come with nice tools for packaging images. How hard could that be? It's all in the manuals. And also Andres had done it the year before. Well, that was a complete pitfall. Wrapping the image and build the executable took surprisingly high times. It was 3 hours the first time. Remember that I was investing 15 hours every 6 weeks, so this was almost the work of a week for the first time. The second time I attempted to move to the following version of Visualworks. Porting the code was easy, but I never could produce the closed image. I couldn't. After 2 hours, 2 hours and a half, I quit. I decided to stick with my old version. The third time, I had all the previous experience, and even so it took me 1 hour. And the following times, that were not many, but 2 or 3 times more, it took me no less than half an hour every time. So the tools are there. They are good tools. They do a very complex trick with the image, but are not easy to use. So here came another lesson to repeat with me. Every time you exit from Smalltalk programming, anything can happen. It's undefined behavior. Well, I published the first version, so I was worried because the players had nice things to play with, but the status report is kind of a barrier because it has lots of information, but you need to parse it if you want to take that information automatically. So I intended to provide a parser. It's a completely different kind of work. It's not programming the simulation, it's not running the game. Here the objective is different. My first goal was that it had to be easy to port to another dialects, because beforehand we knew that any participant would like to do the game in his Smalltalk, not in my Smalltalk, not in Visualworks necessarily. So I wanted it to be easy to port. The only way I could think to be able to do that was writing here lots of S-unit tests and trying to maintain the programming style not fancy. Oh, okay. Well, this is how the status report looks. It's human readable, but boring to parse. The status parsing took 6 hours, 1 week. It was only 11 classes, and it has 17 tests. It was ported to Visual Smalltalk, Visualworks, and 3 other dialects, so I consider that was successful. Well, I added adventures on the following stage. This is the version I produced for the qualifiers round. So it took 70 hours, 5 months of work, and it's still a small model. So this proves again that having a single person project, it's much harder than having a team working on it. I strongly suggest that for the next coding contest, at least a pair of programmers run the project. Well, then I started to develop strategies. Strategies needed to be simple and flexible because I wanted to implement lots of them. So I thought, again influenced by some previous Andres work, on objectives. Objectives mapping almost one-to-one to commands. Every objective is in charge of generating one command if possible. And the strategies are a collection ordered with some criterion of objectives. So I had these possible and initial combinations of objectives. I had a strategy that only works all the time, a strategy that takes adventures every time it can, and if it cannot, then works, and combinations like that. Fighting strategies. And then I produced different scenarios because I wanted players to be evaluated in several different conditions. Scenarios were simulation worlds with a particular set of configuration and a bunch of characters randomly generated but with precisely defined strategies. So remember, strategies are simple, like Space Invaders strategies. They have no feedback, they have no dynamic behavior, they are only a list of actions in order of preference to take, but they raise some complex questions, questions that only reading the code and thinking about it, I don't know how to answer. For instance, which strategy of the handful of strategies that I showed before is better? It's only working better? It's only fighting better? I don't know. How much better? Orders of magnitude? Very few. Are they easy to defeat? Building an intelligent, smart strategy so a programmer working 1 week on this can beat those strategies that are very stupid? Well, all my experience drives me to one answer. Simulate. Run the simulation. Run the simulation and test the thing working. So, repeat with me. Do not try to guess what a complex system does. Simulate it. Measure it. Use benchmarks. And these are some benchmarks. Well, it's not very surprising. The better strategies are fighting and adventuring and fighting only. The only thing that surprises me here is the little parameter, which is the risk level, high, low, or known, proved to be very important. That little parameter that defines a strategy as aggressive or not, and as how willing is to take high-risk challenges, for instance, challenging an opponent which is better than his stats and so on, proved to have a high impact. Well, I will tell some few words about the modifications for the finals round. In finals round, I changed the things for the players to have an additional challenge that forced them to program something here in front of me in 2 hours yesterday. So I produced new scenarios. That was very easy because I described how scenarios are. New strategies that are little variations of the previous ones. I did a little trick, nasty trick, which was changing the letters of the commands in the parser. So when they were used to send A to take an adventure, now they had to send a Q. That's just for fun, because I knew that in 10 or 20 minutes they could figure what were the new letters. I changed the scoring function. I gave a higher coefficient to fame and lower coefficient to gold or something like that, and changing some rewards. Not very significant changes, but the response of the automated strategies varied notably. Anyway, the same two strategies are still the better, but it produces changes. So I had a different game by twisting those parameters. Listo. So that is the end for my part.
We have no time for a few questions. I mean, you can ask something questions. Nobody has a question. There is something that is probably a good idea to explain how all the context works. Would you explain for the next year?
All the context, I don't know.
The context is just to keep in mind that when to participate in the contest, you have to download the
server. Basically, you have to download the server, play with it at home, and send the certificate for the qualifiers round, which had a minimum score to be accepted. Only with that you can go into the finals round. The minimum score at that point was 64,000. It seems a big number, but I took it by looking how automated strategies worked, and it was only 3 times that the most stupid of them can do, so it was very easy. Actually, I think that nobody should invest more than a weekend to get a certificate valid to participate. So we try, Andres and me this year, to do things that do not take as much time from the participants as it takes from the coding contest organizer. It's easy to participate, and I strongly encourage you to do next year, because it's some fun and some work on a few weekends, and you can have interesting experiences and also take an iPod to take you home. Prizes are interesting also. They are donated by our sponsors and are very nice stuff.
How did the simulation work, and how did the participants' characters play? It was a server of the world live online, and they remotely acted on the world? Or did it send you the
no,
characters?
Let me see if I can have this work. No, they run an executable file, which is the server, and then using the browser they can send commands by hand, or they can use an automated player that I provided as example that talks HTTP and sends the commands. So you just give him the string and he raises.
You start up the server locally?
Yes. You start up your image and run.
Make the player send commands?
Yeah. Yes, but basically a loop around every step of the scenarios.
That produces a certificate. When you are happy with your certificate, you apply.
You send.
And if the certificate is good enough, you are a finalist, and then you win the item.
And in that simulation, that's where all the players you created are.
Yes, they live only in the server.
And do the different participant players fight each other or compete in the same
No,
time?
that was my original idea, and that would be very nice. It actually can work that way, because you can have the server in a network and coordinate the players to connect to the same server, but it requires a level of robustness that I don't have, that I cannot provide. So I decided to not do that, because if every one of the players does something bad, they compromise the server for the others. So accidents happen every time.